Hi everyone, and welcome to positron emission tomography. What is positron emission tomography? Well, for a short brief, it is basically a way for doctors to visualize what is going on in your human body based off of a chemical reaction that goes on when they inject you with a chemical compound that usually either has something to do with your glucose level. But before we go into exactly what a PET is, different ways of using a PET scan. So a lot of grad students use this kind of simulation, which is called a Open Gate Collaboration Simulation, which is a free online software that any master's or PhD student or doctor of any sort can use to simulate different ways that the human body reacts to a PET scan. So those lasers that you saw in the previous picture was different gamma rays being emitted from the body because of the chemical reaction it was having. And that way doctors can see on their computer screens exactly where those two gamma rays are emitting from. And then from those visualizations they can kind of determine what type of disease or, whatever harmful thing you might have in your body. So the Open Gate collaboration is a use of a PET scan. It allows medical physics students to simulate different types of PET scans. So it allows us to advance our current medical technology. It is used at UC Davis currently in their medical physics program, and we are just starting to use it here at SDSU at our medical physics program as well. And this picture here is a picture of a chemical compound that your doctor would inject into you. This here has fluorine 18. Fluorine 18 is injected into the body and it causes two characteristics of annihilation: photons to be emitted from a point where the chemical has been concentrated by psychological processes. This can measure exactly the location of wherever your two gamma ray photons are going to be emitted. So for example, if they're emitted from the brain in a certain way, you can kind of detect whether or not you have Parkinson's disease. At the top you can see that that's a normal brain, there's no disease in there whatsoever, and then the brain just below it is kind of like pre-Parkinson's disease. It hasn't quite taken over the brain yet, and then post-Parkinson's disease below, you can definitely see the brain is shrunk, there's a lot more red and green. And same with this. This is a Alzheimer's disease analogy. On the left, you see a normal, lovely human brain, very spongy, very good for absorbing knowledge. And then in the middle, you kind of see some cognitive impairment. You see some black matter in there, and then you see the Alzheimer's disease brain, and you're like, whoa, there's a huge gaping black hole in this person's brain. Well, they probably don't remember their own name at that point, which is really bad. So, a PET scan can determine Alzheimer's disease and exactly what level you are at. Parkinson's disease, same thing. It can also measure strokes, brain tumors, brain lesions, cancer. I mean, the tool for using a PET scan is kind of limitless at this point. We just have to figure out a way to, make the most use out of it. So I'm going to go back to that first question I had of how this works. And as you can see here, a positron emitting radioactive chemical is injected into the body. Cause two characteristics annihilation photons to be emitted from the points where they have been concentrated in the brain, some point, some way. The point we measure is the two gamma rays that are photons that exit the body. And what happens is they get absorbed into the chemical crystals that are what we call a PET scan. And then through this, we are able to calculate the exact origin of where those two gamma rays came from, which is so rad. So thanks, and have a lovely evening. Goodbye.